Here we have example 6 of our module 4 class notes, and I am officially tired of graphing rational functions. So if you are too, then welcome. But I want to give you as much information as possible, as much practice as I can to give you more practice, more confidence with graphing these rational functions. So I will suck it up. And here we go again with example 6. Make sure that you've watched example 0 to get the vocabulary and characteristics of an introduction to the graph of rational functions, and we'll take it away from there. We are going to, first of all, factor the numerator, factor the denominator. You do that, and you've got a GCF in the numerator. And you've also got a GCF in the denominator, which further factors to a difference of squares. And we have this as factored as possible form of our function. From there, we can find the domain by recognizing the denominator can't be 0. 3 can't be 0. That doesn't give us any information, but now we know x can't be -2 and x can't be +2, so we set up our intervals, our unions of intervals to exclude -2 and exclude +2, and we've got our domain in interval notation. Next up for the intercepts, we find the y-intercept by plugging 0 in for x. And doing the math there, looks like we end up with 94 over -12, which reduces to -47 over 6. And yes, one reason we're working this particular problem is that we're getting ugly numbers. It's okay. You don't have to be scared of ugly numbers. They work just as well as pretty numbers, especially when you have a calculator to understand a good approximation, like -47 over 6 is almost -8. So my y-intercept is 0, almost -8, -47 over 6, and that's going to help us with the graph of the function. And then for x-intercepts, we let y be 0. We set that fraction equal to 0, which, as we've done before, means we focus on the numerator and set the numerator equal to 0. Since 2 can't be 0, all we have to do is look at 47 minus x squared equal to 0. Add x squared to both sides. Take the square root. You get x equals plus or minus the square root of 47. Yuck. But that's okay. The square root of 47 is, and you can double check this in your calculator, the square root of 47 is almost 7, because 49, square root of 49 would be 7. So square root of 47 is almost 7. So we've got two x-intercepts, one at positive square root of 47 comma 0, and one at negative square root of 47 comma 0. We will use that information along with information we find now about the asymptotes, which work out a little bit nicer, definitely, with our vertical asymptotes occurring at the points where the denominator is 0. So we set x plus 2 equal to 0, we set x minus 2 equal to 0, and we get x equals -2 and x equals +2 for my vertical asymptotes. For the horizontal asymptote, we note that the degree of the numerator is 2 and the degree of the denominator is 2. So we take the fraction of leading coefficients, which will be -2 and +3. The fraction there, -2/3, then y equals -2/3 is our horizontal asymptote. We've got all the asymptotes and all the intercepts. Let's plot those puppies and see what our graph looks like. All right, here's what we've got so far. Now let's find some additional points and see how things shape up. Actually, we can, from here, if I was a betting man, I would probably go ahead and fill in the information here because I know from these points we're going to approach the asymptotes. And for that middle section in particular, here, I know that we're not going to go back up and cross the axis, or else we would have found more x-intercepts. So I'm pretty sure this is going to curve down. And I'm pretty sure I can sketch a curve on the right approaching the horizontal asymptote and the vertical asymptote, and similarly on the left. But let's plug in some numbers just to be sure. When I use -3 for x, input -3 for x, I get 76 over 15, which I've just given up now, and I went ahead and said plug it into my calculator, and that's approximately 5.1. I can do that on my graph. I can plot the point -3, 5.1 on my graph. Plug in -1 for x, you get 92 over -9, which is about -10.2. Plug in 1, and you also get about -10.2. Finally, plug in +3, and you once again get +5.1. So we've got these points on the graph that actually shape the graph up to about what I was expecting, curving toward the asymptotes in all of these different branches.